All right, so let's start off with an introduction to active learning, right? So what exactly is active learning? So if you think about any machine learning system, any standard machine learning system, it operates in 2 steps, right? The first step is called a training step, where you train a model, and the second step is called a testing step, where you test the model. So the training step itself consists of 3 sub-steps. You can think of that as consisting of 3 sub-steps, where you collect, the first step is to collect some data, right? If you want to train your model, you need some data. The second step is to label the data, because you need to kind of annotate the data. The model needs to know which, and let's say we are working with image recognition as an application. So the model needs to know which sample belongs to which class or which category. And once you have the labeled data, you can train your machine learning model, any deep learning model or any kind of model that you want. Right? And once your model is ready, you can deploy the model in a testing environment, and the model is going to give you predictions. And if the model is well trained, hopefully it's going to give you a reasonably good predictions on the test data. So this is how a typical machine learning system looks in a nutshell. But during the training step, the second phase is extremely crucial, because the data is typically hand labeled by human experts, and human labor is very expensive. So today we are talking about deep learning, different kinds of deep neural networks, but deep neural networks are extremely data hungry. You need a lot of labeled samples to train them. And getting annotated data is extremely challenging. So how do we go about developing intelligent learning systems, intelligent machine learning algorithms, under the constraint that getting labeled data is challenging? That branch of machine learning is called weakly supervised machine learning. And what I'm going to present today or talk about today is active learning, which is a type of weakly supervised machine learning algorithm. So just to demonstrate the idea through an example, let's say we are working on medical image classification. We want to train a deep learning model which will predict whether a given medical image is a cancer image or a non-cancer image. We need an experienced doctor to label a lot of samples for us. And as we all know, experienced doctors are rare and busy. So we can't really expect a doctor to hand annotate a lot of samples. So here, weakly supervised machine learning becomes extremely important. You need to develop systems. You need to develop a reliable prediction model, a reliable deep learning model, but you can't expect a human annotator to give you a lot of samples. So just to draw a comparison with passive learning, what happens in a passive learning scenario is the passive learner receives input from the world, and it outputs a model or a classifier. Okay? In contrast, in an active learning setting, the active learning queries the world. So it kind of asks questions to an annotator and receives responses, and then it outputs a model or a classifier. So this extra capability of the active learner to adaptively query the world and receive responses makes it better than a standard passive learning model. Okay? So let me try to demonstrate the typical setup of active learning. So this is how a typical active learning setup looks. Okay? You have a small amount of labeled data, which is shown by the green points here. So you have some amount of labeled data to start with. So those are samples whose labels are already given to you. You have a lot of samples shown by the red circles, which are not labeled. So that's an unlabeled pool of points. So those are the samples whose labels are not known to you. And there is a human annotator in the learning loop who can label samples for you. But the human annotator cannot label all the samples. So there is a budget that is given to you. So let's say you have n number of samples, unlabeled samples, and your budget is k, where k is much smaller than n. The human annotator can only label k samples for you. So what happens in active learning is you select a subset of k samples, give those to the human annotator who labels them and puts them into the training set. And this process kind of continues until some budget constraint is satisfied. So this is how a typical active learning setup looks. Okay? So the fundamental question that we are trying to answer here is, given an unlabeled set of points, n unlabeled points, and a query budget k, which is much less than n, how do I decide which k points should be picked and given to the annotator for labeling? That is the main question you are trying to answer in an active learning system. The applications of active learning, I think it's extensively used in a variety of applications, extensively used in computer vision applications like medical imaging, like image retrieval, face recognition, extensively used in text mining applications, and basically any application where you have a lot of samples, but labeling data, getting labeled samples is a challenge. You can use active learning. Right? And talking about applications, I should mention here that Amazon, if you have used Amazon tools from Amazon, Amazon has a tool called the SageMaker, right? It's basically a machine learning service that which you can use to very easily train your machine learning models and deploy the model in a testing environment. And the SageMaker actually uses active learning to label samples. That is an example of a commercial tool, a commercial application, which uses this kind of a technology. Now, if you take a look at past research on active learning, so researchers have mainly attacked this problem from three different perspectives. The first and the most important research paradigm in active learning is that of designing query functions. So how do I decide which samples to query? How do I come up with a strategy to decide which unlabeled samples should be queried and annotated? So people have looked into uncertainty-based query strategies where the idea is I'm going to query the samples where my model is very uncertain or the model is not sure about the label. People have also looked into diversity-based techniques where the idea is to query samples that are diverse so that I don't end up querying samples that are redundant. Representativeness techniques where people attempt to query samples which represent the underlying data population or the data distribution well. So all these are different query functions that people have designed to decide which samples to be queried. Researchers have also looked into different kinds of label spaces. So I could be solving a classification problem. I could be solving a regression problem, image segmentation problem, multi-label learning problem, object detection problem. So these problems are very different, right, in the task that you are trying to solve. So the active learning algorithms that are developed on top of this will also be very different. So how do I go about developing active learning algorithms for these kinds of label spaces where the label spaces are a little different? Okay? That's also a very active area of research. And people have also looked into different problem setups. So the setup that I showed in the slide before is called pool-based active learning, where you have a pool of unlabeled samples. All the unlabeled samples are known to you. And then you iteratively query samples, give those to an human annotator who annotates them and puts them into the labeled set. There are two other variants of this, which is very relevant in today's world. The first one is called online active learning. The idea in online active learning is you don't have access to the entire unlabeled set all at once because the data keeps coming over a period of time. And what you have is a buffer with limited memory. So on the fly, as data samples are coming, you have to decide which samples to query and which samples to discard. This is a very challenging problem because when you see a particular batch of samples, you don't really know what is coming next. And also, once you discard a sample, that sample is not coming back. So on the fly, you have to take a decision that is final, right? And on the fly, you have to decide which samples to be queried and annotated. That's a very challenging problem. The other challenging problem is distributed active learning. So in today's world, we are generating lots and lots of data. It's not even possible to fit the data in one machine. So what if I have a system or a scenario where the unlabeled pool or the unlabeled samples are distributed across multiple machines? I don't have one machine which can hold the entire unlabeled set. So how do I go about developing an active learning technique where the unlabeled data is distributed across multiple locations? So these are all existing areas of research that people have been working on. Okay, just to give you a high-level overview. So let me talk about some current and future research directions in this area. Now, how does a conventional active learning query look? Let's think about that. So let's say we are working with image recognition. I'm going to take image recognition as an application because I extensively work with computer vision data. Okay? So we have a bunch of images and we want to train a machine learning model and we want to do active learning on top of that. So there is a human annotator who can give you labels. So conventionally, what happens is we pick an unlabeled sample, we give that to the human annotator, and the annotator gives us a label. Okay? And that sample goes to the training set. We again pick an unlabeled sample, give that to the human annotator who labels it. We keep doing this until some stopping criterion is satisfied. Okay? This is kind of a very idealistic scenario. Turns out, real-world applications are much more challenging and much more complicated. And this ideal scenario may not hold in many real-world applications. And I'm going to demonstrate that through a few examples. Okay? Okay, actually, let me talk about the application. So the application that we are interested now is an application of estimating age from facial images. So you are given the facial image of a person. You have to predict the age of the person. It's a very well-researched problem in computer vision. And not surprisingly, deep learning models have done really well in this area. Okay. So now let's say we want to train a deep learning model, a deep neural network for facial age estimation. Okay. So we have some small amount of labeled data, a lot of unlabeled data, typical active learning setup, right? And we have a query budget K, which is the number of samples the annotator can label. And let's say you all are the human annotators, okay? And the active learning algorithm is running. So the algorithm has picked this image and asked the question, what is the age of this person? What would be your answer? 45? 37. 45, 37. What else? 26? Okay. You see the problem, right? So this is an example of an application where if you pick an unlabeled sample and ask the question, what is the label? You may not get a very reliable answer. Okay. And if you train the model with that label, and if the label is incorrect, that incorrectness will propagate into your model, and you may not get a very good model. So this is an example of an application where the conventional active learning queries may not be very efficient. You may need to design very specialized queries which are tailored to an application like this. In fact, to demonstrate this, we did a small user study where what we did is we crowdsourced about 15,000 images like this, and we asked people to give us what they thought were the age values of these images, like the subjects in these images. And this is an error histogram we got. So what this shows is the y-axis, the vertical axis shows the count, and the horizontal axis shows the error value, how much error people made in years. You will note that for more than 5,000 subjects, the difference between the actual age and what people thought the age was more than 10 years. 10 years or more, if you take a look at the last bar, right? So this shows that how much error can be there in this kind of a human annotation. And if you, not surprisingly, if you train a model with this kind of an annotation, your model is not going to work well. Right? So how do you kind of develop better query systems or better annotation systems for problems like this? So perhaps one better way to ask the question is, you pick an unlabeled image, and instead of asking what is the exact label, you ask the question, provide a range. Like what can be the range of labels? Like this person looks to be in his 40s or 50s or whatever. So instead of asking for the exact age, you ask for a lower bound and an upper bound. And there is a better chance that you can end up with an annotation with a higher quality. Another possible option may be you pick two images and ask the question, which one do you think is older between these two subjects, right? So all these are annotations, all these are query mechanisms which can get you better annotations in this kind of a setting and potentially can get you a better model rather than asking the question of what is the age value of this person. So this is one example where kind of conventional active learning queries may not be very efficient. Now let me demonstrate that through some other examples. So image segmentation is also a very well-researched problem in computer vision. So the idea is you're given an image like that, and what you want to produce is a segmented image shown. So basically you have to label every pixel in the image. And once again, deep learning has done extremely well. There are a variety of deep neural networks. I think there's one model called DeepLab V3+ that has done really, really well. And let's say we are trying to do active learning on top of this problem, right? So if you're doing an active learning on top of this problem, what you're essentially looking at is the active learning algorithm will pick an image and ask, give me the label of this image. Essentially what you have to do is you have to segment that image. And that can be extremely tedious. That involves a lot of manual work because you have to segment every pixel. It's not like taking a look at an image and saying, this is the image of a cat or a dog. Right? This is an application where you have to provide labels to every pixel, which can be extremely tedious. In fact, the bottom image here is from a data set that is called Cityscapes. It's a very popular data set for image segmentation, right? And the paper was published in 2016 in the CVPR conference. And the authors have mentioned that to annotate one image, it took them about 1.5 hours just to annotate one image. So it kind of begs the question about how can we come up with more efficient annotation mechanisms? And one way to do that may be to identify parts of the image, identify segments of the image where the annotation needs to be done instead of annotating the whole image. So you can pick an image together with some informative segments and ask the annotator to label only those segments. So that can be a better way to request labels rather than requesting the annotator to annotate the whole image. Now, let me show one more example. So the problem we are looking into now is we have a piece of text, right? That's a review, basically. So someone has gone to some, let's say, hotel and written a review. We write reviews all the time, or someone has rated a movie. And we want to develop a deep learning system to classify the review as positive or negative. Okay? And this is one example. So let me read this. This one, someone has gone to a hotel and written a review about a hotel. The review says, the hotel was perfect for a short break. The city center is a short hop away on the regular shuttle or a quick ride by taxi. The staff were very welcoming and friendly and helped with advice on the many things to visit in the area. We also enjoyed the meals in the restaurant. We would certainly come back here for another trip. All in all, a tranquil spot close enough to the buzz of the center. Now, if you give this piece of text to a human annotator and ask for a label, most likely the answer is going to be positive. This is a positive label. But if you take a look at the data, it was perhaps not necessary to read the entire piece of text to come up with a positive answer. We could have perhaps presented some snippets of the text and asked the user what is the label. That would have been a much better usage of the human annotation effort, right? This is another example where specialized query mechanisms are necessary. And I'll just conclude with one last example. So the problem of interest here is object recognition again. So we have a data set of images containing objects, and we want to develop a deep neural network to train, to recognize the different classes of objects. But the problem is the data set we have is a data set like ImageNet, where there are thousands and thousands of classes. And the human annotator may not be knowledgeable about all the classes. It can have some objects of some weird category or some uncommon category, which the user may not be familiar about, and will most likely give you the wrong answer, right? So for example, let's say it queries this image. Any idea what this is? It's a thimble, right? Yeah, but not everyone will be able to answer this perhaps, right? So a slightly better way to pose the question maybe to identify an unlabeled sample together with a reference image and ask the question, do they belong to same or different classes, right? So this is a much better way to pose the question in an application like this. And people found this to be highly effective than other types of annotations. So this is another example of an application where specialized query mechanisms are necessary for better annotation and potentially get better models. So this is an area of active learning that has been gaining a lot of attention in recent years. How do you develop specialized query mechanisms for active learning? So with that, I'll conclude. Thank you.